Hey, hi, good morning, everyone.
Good
So,
morning.
I'm assuming that for you guys, stats and machine learning is completed, right?
Yes,
Okay, nice. Cool. Today what we will be starting with is the time series modeling. Okay. So, time series modeling is actually, I would say, very much related to machine learning because it is, at the end of the day, it is modeling, right? But it is at the same time very different from machine learning as well. Okay. Why it is very different is because when we learned machine learning for the first time, right? Like someone told us that there is going to be a target variable, there are going to be input variables, right? And then we will be using the input variables to predict the target variable, right? This is the basics of machine learning. There will be a set of inputs, there will be one target variable, and we will be using those inputs to predict the target variable. And there are different algorithms to find that relationship, right? To find the relationship between input variable and the target variable. If you look at linear regression, logistic regression, or decision trees, or boosting techniques, right? Like anything that you will pick from machine learning, you will realize that at the end of the day, you were just trying to find the relationship between input variables and the target variable. That is what I would say, the basics of machine learning, right? So, how time series is different from rest of the machine learning techniques is because in time series, we do not have any input variable. Okay. We have just a target variable over a period of time, and we are looking at that trend over the period of time and trying to predict what will happen next, right? So this is how the time series is going to be different from your usual machine learning techniques, right? it it ideally doesn't fall into classification as well because you know it is not like your logistic regression. At the same time, it purely not a regression either. Okay. But still, if you would have to put it into one of the buckets between classification and regression, we will put it in a regression bucket. Okay. But ideally, people try to avoid it in putting it into either classification or regression. Okay. Now, in a time series, in general, there are going to be three components. Let me write it down. In all the time series, there are going to be three components. One is going to be the trend component, right? By trend component, I mean that whether a time series is increasing over the period of time or decreasing over the period of time, right? Or maybe constant over the period of time. If you look at the revenue of a company, right, it can increase or it can decrease or it can remain constant, right? These are the three factors in general. So that is a trend component. The other component is the seasonality component.
you are sharing anything, Puneet?
Oh, oh, sorry, just 1 minute. I'll just share my screen again. Yeah. So the other component is a seasonality component. If you look at the sales of, let's say, for example, AC, right? Uh, you will see that there is a spike in AC sale every year at the time of summers, right? You will see a spike in sales, and then again the sales will die down at time of winters. Again, it will go up in the summers, and again it will die down in the winters, right? So there is a cycle, right? Or seasonality, we like to call it in case of time series. And the last component is the randomness. Okay, randomness is nothing but something that you cannot predict. It is going to be random, right? It can sometimes be positive, it can be negative. Sometimes it is a small, it is number. It is sometimes a little big number, right? We cannot predict the randomness. Now all the time series are made up of these three components. Now these three components can either be combined together in an additive way or a multiplicative way. Okay, I'll show you the examples. So these three components, trend, seasonality, and randomness, can either be combined together in an additive way, where let's say we will be saying the trend component plus the seasonality component plus the randomness component is making our time series. Or these three can be multiplied together to make a time series, where we will say it's a trend component multiplied by seasonality component multiplied by randomness component. Okay, so it can be additive time series, it can be a multiplicative time series. Okay, there are different ways to solve both of these, and we will discuss that. Now, okay, let's take this as an example. So there is a trend component, there is a seasonality component. Trend component is either the sales will be increasing or decreasing or constant, as I said. Seasonality component, it will at equal interval it will go up and then go down and then again go up and then again go down and so on. That is called seasonality, right? And finally the random component, where the values are totally unpredictable. We don't know what is going to be the next value. Okay, now if I combine all of these three together, you will see that I will be able to form something like this black line, right? So there is a trend. If you'll see that it is increasing over the period of time, then there is a seasonality, because you will see that sometime it is going up, sometime it is going down, and a small variation here and there, right? This line is not a smooth line. There is a lot of noise here, right? That noise is nothing but your randomness. Right? How knowing this thing is going to help us is, let's say, this. In any time series modeling, what we do is we have a time series and we want to predict what is going to happen next, right? That is what our prediction is. Like, I have data from time 1 to time 2, and I want to predict what is going to be the values from time 2 to time 3, right? All the time series modeling will have this as a problem. Data is present from time 1 to time 2, and we want to predict what will happen in this time period. And how we will make that prediction is very easy. We will take a time series and we will decompose it. Okay, what we will do? We will decompose it into three parts: the trend component, the seasonality component, and the randomness component. Okay, decomposition means we are separating it out. It was combined together like this. We used like let's say there is a method to do it, right? So let's say we use some method to decompose the time series into three parts. One is the trend component, right? One is a seasonality component, and one is a randomness component. Now, if there is a line like this, if there is a line like this, can you predict what is going to be the next value,
Yes.
right? If there is a line like this, it is easy for us. Like here, it is a little difficult. What is going to be the next value? But if I forget about this and focus on this chart, if someone will give you this blue line, can you predict what is going to be the value of this blue line from time period 2 to time period 3? The answer is yes. It is relatively easy. If you look at it, it is nothing but regression, right? This is nothing but regression, where we are trying to predict a line, a trend. And then the other component is the seasonality component. If I will give you a trend like this, right, a pattern like this, can you predict what is going to be the next value? The answer is yes, right? Because the best part about seasonality is that it repeats itself. It repeats itself. If you look at it, there is this cycle, a U kind of a thing, which is repeating itself. So I can just keep on drawing that U and I will be able to get the next value, right? And what about the randomness component? Can we predict what is going to be the value next?
No.
No, right? Because randomness cannot be predicted. Okay. That's why the name randomness. We don't know whether the next value is going to be a positive value or a negative value, a big value or a small value. We don't know. Right? So we cannot predict that. No machine learning technique can predict randomness. If it can, then it is no longer a random component. If you can predict something, then it is not random. Okay, so randomness here means something, that component of time series which cannot be predicted by any machine learning technique. So now what I will do, I have this blue trend. I extended it from time period 2 to time period 3. I had this seasonality trend. I extended it from time period 2 to time period 3. And I had this randomness trend, but obviously I cannot predict it for the future. But now what I will do is I will combine these two components together. The trend component and the seasonality component. I will combine these two together to make my prediction. Okay, that's the reason if you look at it, right, the actual time series versus the predicted time series, the predicted time series is very smooth. Okay, it is very smooth. On the other hand, the actual values has a like a lot of noise. And the reason behind that is that we are not being able to predict the randomness. Okay, so instead of we trying to predict the actual time series, what we did was we decompose the time series into three parts: trend component, seasonality component, and randomness component. And then we predicted whatever we could. We predicted the trend component, we predicted the seasonality component, right? And then we just combine those two predictions together to make our prediction for time series. Is it clear to everyone what we are doing over here?
Yes, clear.
Yeah. So here there is no input variable as such. Okay, we are using the same variable, the target variable itself, right? We are using the target variable itself to predict it, to predict the target variable, right? And that's why it is also called auto regressive, auto regression. It means that the target is regressing on itself, that the target is being used to predict the target. Okay, auto regression. Because I'm telling you this term because this term you will be seeing a lot whenever you will be reading anything related to time series. The series is a auto regressive technique. Okay, so this word sounds very heavy, right? Something called auto regressive technique that we are going to use in time series. It sounds very heavy. Okay, but the meaning is very simple. The meaning is very simple, that there is no input variable. We will be using the target itself to predict the target. Okay, now I said we will decompose it. That is the first step. Second step is to combine it to make the prediction. Okay, and we will be seeing both how to decompose the time series as well and how to combine it as well to make the prediction. But one thing that we need to remember is when we are combining or decomposing the time series, before that, we would have to make an assumption. The assumption is going to be whether my time series is a additive time series or my time series is a multiplicative time series. Okay, that is the assumption that I would have to make first. If my time series is additive time series, I'm going to combine the three components together like this. If my time series is a multiplicative time series, I'm going to combine the three components together like this. Okay, both will use a different method. So that's the reason before starting our prediction, before even starting our regression, we need to make an assumption whether our time series is an additive one or a multiplicative one. Okay, there are methods to kind of tell you whether it is going to be additive or multiplicative, right? But those are not short methods. So what most of us do practically is, right, we will solve the time series once, assuming that it is an additive one, and then we will solve the time series assuming it is a multiplicative one, and then we see where we are getting the best accuracy. Right, so we try both, and then we see which one is giving you the best accuracy. Now, if let's say this is a additive time series. If you look at it, the values are always in a channel between this green line and this green line. Okay, this is also a time series, but the values are always within this channel. On the other hand, multiplicative time series will look something like this. Here the values are also in channel, but the channel is increasing over the period of time. Okay, so this one is additive, this one is multiplicative. Right? By looking at a time series also, we can make a guess. But honestly, here they have taken a very simple example. In general, it is a little difficult to figure out whether it is going to be a multiplicative or additive time series. Sometimes it looks like a multiplicative one, but it is an additive time series. Okay, that's why I was telling you. Practically, what we do is we try both. We try using assuming that it is an additive one and then solve the time series. We try by assuming it is a multiplicative one, then solve the time series and see that which one is giving us the best accuracy. Okay, next is the same example. The above one is a multiplicative one and below one is a additive one. Okay, now what we will do is we will try to do the same thing in an Excel first. Okay, we'll try to solve time series in an Excel first, and then we will try to do it in to solve it in Python. Okay, I'm sharing one file with you. Please download it. Okay, I've shared one file with you. Please download it. Okay, I hope you have it open. Now, what do we have is we have this time series. Okay, if I will plot it, this is how it will look like. See, okay, we already have it here. Anyway, all right. So we have this time series. If you look at it, it is slowly increasing over a period of time. That means that it has a trend component. I can see some seasonality as well.
Puneet, are you sharing your screen?
I don't know why it is getting stopped in between.
No, it was visible.
It was visible?
Yeah.
Okay, cool.
No, sir, it's not visible.
Yeah, now it is visible.
Okay,
It's
it's
visible.
fine. I hope it is visible to everyone now, right?
Yeah.
So I hope you have that Excel open. Now, what I was saying is that if you will plot this time series, let me show you again. I just selected this data. I went to insert, right? So if you look at this time series, it has a trend component as well because it is increasing over a period of time. It has a seasonality component as well because if you look at the cycle, right, it is going down and then again going up, again going down and again going up, right? So we can see some seasonality here, right? So now what I will do is there is a random component as well, but obviously we are not being able to see it because the data points are less. Now, what we need to do is, if I want to predict, if I want to predict what is going to be the value of of my sales in the next quarters, right? What I need to do is I need to first split this time series into three components, actually two components. Okay. One is the trend component and the seasonality component. Because random component, anyway, I will not be able to predict. Okay. So I will split this data into trend component and the seasonality component. How we are going to do it? We will first going to take out the trend component. Okay. We are going to first take out the trend component by using CMA. CMA is nothing but centered moving average. Okay. Now, let me maybe show you here. Just give me a minute. Uh, are you guys being able to see the Chrome or Firefox that I've opened?
Yeah.
Okay, cool, nice. Okay, so if you look at it, even a stock chart, right, stock price chart that we have is nothing but a time series, right? Because over the period of time, the values are going up or down. Even there, if you look at it, if I want to get the trend component, if I want to get a trend component, we use moving average. Okay. Like for example, 50 days moving average, 20 days moving average, 200 days moving average. What moving average will do? It will just show you the trend component that whether over a period of time, the stock price is going up or is it going down. Right? Let's say, for example, over here. Right? Like this. So if someone will ask me to predict, let's say, the actual stock price versus to predict, let's say, this purple line or pink line, right? Which one is easy? It's easy to predict, let's say, this orange line or this pink line as compared to, predicting the actual stock price, right? But the main thing that I wanted to learn from this is that in any time series, if you will take moving average, you will be able to find the trend component. Okay. In stock price, we take, let's say, 50 days moving average, 200 days moving average. We take out the past data. Why we look at the past data? Because future data is not available. Okay. Here, because we are we are doing the analysis on the already on the past data, what we can do is we can use centered moving average. So there are two types of moving average. Let me show you. Maybe let's say sales is there. Okay, there is something called moving average, and let's say moving average of 5. What is the meaning of that? That I will be taking previous 5 values, right? Let's say assuming this one as well. Previous 5 values, and I will take an average of that. This is, okay, this is nothing but 5 days moving average. I could have done 10 days moving average as well. In that, I will be taking average of last 10 days of values. I will take last 10 days of moving, right? So if you look at the 5 days moving average, it is like this. At any point of time, I'm looking at the last 5 days and taking an average of it. If I look at the last 10 days moving average, at any point of time, I'm looking at the last 10 days and taking an average of it. There's something called centered moving average as well. Right? Centered moving average is nothing, but I will be taking, let's say if I'm taking a centered moving average of 5 data points, then I will be taking 2 data points from past. One is the current data point and 2 data points from future. Total 5 data points, right? 2 data points from past, 2 data points from future, 1 data point of the current value. This is called centered moving average. Okay, let's say this. And I think you might have guessed how I'm gonna do now centered moving average of 10. Right? Now, when we are taking a even value, like for an odd value, it was very easy. Let's say if it is 5, then 2 in the past, 2 in the future, 1 in the center. If it is 9, then 4 in the past, 4 in the future, 1 in the center. But if it is an even value, then you would have to either take, let's say, for example, if it is 10, then you would have to take either, let's say, 4 values in the past, 5 values in the future, or maybe 5 values in the past, 4 values in the future. Okay. So there are going to be uneven number of values from past and future. For an example, I'm making 10 days moving centered moving average. It means that I need 10 data points. If I will take 5 values from the past, like this, then I already have 6 values now. All right. It means that I can take only 4 values from the future. Okay, let me show you again. If I'm taking, this is a centered value, then if I will take 5 values from the past, so there are already 6 values now, right? 5 these, this one is the 6th one, and there are going to be 4 values from the future, right? So either this we can do, or we can do, what we can do is, I can take the current value, then I can take four values from the past, and I can take five values from the future. This we can do to get the 10 values. Both the ways are fine depending upon what you are trying to do. Okay, but yeah, this is what the problem is in general with center moving average with the even number of values. So in general, we try to keep the odd number of values like 5, 9, 7, something like that. I could have written over here centered moving average of 9, but then you might have thought why we here kept 5 and 10 and here I'm saying 5 and 9. Okay, that's why I'm explaining that with the even number of values, this problem will always be there. Okay, so we saw in this stock market stock price chart that the moving average can give you actually the trend component. And the best way to get the trend component is using a centered moving average. Okay, now I'll go here and calculates this, right? Two values from the past, two values from the future, and one is a current value. So total five values I'm taking, and I'm taking an average of it. That is my trend component. This is my trend component. I'll just copy paste this to the other rows as well. I cannot go beyond this, right? Let's start from here, right? Five values, five values, right? Five values, five values. Now, if I will try to go beyond this point, right? Let's say if I'll copy paste it more, you will see that actually it has only four values. Okay, that's the reason I just stopped here. That's the reason we just stopped here. And that's the reason that we are not starting from the top as well. We are leaving two values in the starting. Clear? So this is your trend component. Let's say if I want to show you maybe. It's not letting me expand it, but let's see if this is how we can plot it. Yeah, right. So this is our sales, and this orange line is nothing but our trend component, right? Which makes sense more or less. Now the next component is the seasonal. Like I'm assuming here the time series that we have is a additive time series, which means the season the sales value, the sales value that I have is nothing but the trend component plus the seasonality component plus the random component, right? Now if I know that the trend component out of it, then what can I do? What I can do is, so this is right now this sales is equal to trend plus seasonality plus randomness. I can also write it in this format. Sales minus trend component is equal to seasonality plus randomness, right? So what I'm gonna do next is just subtract the actual value minus the trend component, and that will give me seasonality plus trend. Can you do that?
Can you please repeat the last two concepts, please?
Sure. So what I was saying is that there are two types of time series. One is the additive series, one is the multiplicative time series. Right now, we are solving the problem by assuming, we don't know, okay, by assuming that this is a additive time series. If it is a additive time series, I can write this as we can just simply say sales is equal to trend plus seasonality plus randomness.
Yes.
Clear?
Yes. Yes. Yes.
If I will just rearrange it, let's say if I'll take the trend component on the left hand side, so this will become like this,
Hmm.
right?
Yeah.
So I'm doing exactly the same, that I'm calculating seasonality plus randomness, that is this part, by doing the actual value, that is the sales value minus the trend component.
Okay.
Okay. It's clear to everyone?
Yeah.
If yes, can you please calculate it in your Excel?
Hi, Puneet. Can you please go back to sheet one and show the formulas again?
Yeah, just the,
Yeah, so the
hmm,
moving average is just you're picking
hmm,
five cells here,
right,
and when it comes to moving average of 10, you're choosing 10.
right.
And how about center? Like you're
We are
doing the
taking, let's say,
average.
two values from past, two values from future, and
Right.
one current value.
Yeah. For centered moving average of 10.
It is going to be either five values from past, one value current value, and four value from future. This is one way. Or it can be, sorry, this should be four values here. Not C6, but C5. Four values from past, one current value, and five values from future.
Okay, so here like there goes three inputs for average.
Right, right. No, I was just showing you that either we can take four values from the past and five values from the future, because we have even number of values, right?
Yeah.
We have even number of values, that is 10. I took one out of it because one is the current value.
Mm-hmm.
Now I'm remaining with the odd number of values. Now, odd number of values, I cannot divide it equally in the past and future, right? So it is going to be unequally divided. Either four values from past and five values from future, or five values from past, four values from future.
Okay. Okay. So if it would have been centered moving average of 9, then just two parameters inside the average
Yes,
formula.
yes, 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 yes. Right.
Okay. Good. Understood. Thank you so much.
Sure. Now, is this clear to everyone that why we are subtracting the actual minus the trend component? Yes, centered moving average is nothing but a trend component here. I can put it here as well. And maybe, okay, this is the trend component. Now, what we have got is we have got seasonality plus randomness. Okay. Now, the best part about randomness is it is sometime positive, it is sometime negative, right? You must have seen the errors in linear regression. Have you seen the charts of error in linear regression? Yes or no? Residual errors. No?
Outliers, you're saying?
No, no, no. So what happens is that in a linear regression, you are trying to fit a trend to a set of data points, right?
Yeah.
Let me maybe show you. Maybe the regression, right? If you look at these data points, any data points actually, these data points, are these data points in a straight line? No, right?
No.
So, but you are trying to fit a line through it. Let's say if someone will ask you tomorrow, what is your prediction for the value of x is equal to 2? So what you will do is you will just go straight up, and wherever this line is there, you will say that is what my prediction is.
Yes.
Clear to everyone, right? In a linear regression, this is how we do it. That we have a lot of data points. Are we trying to join these data points like this? No, we are trying to fit a straight line through it. We are trying to fit a straight line through these data points. And if someone will ask me for x is equal to 2, what is the prediction? The answer will be very simple. I will just go straight up here. And this is what my prediction is for x is equal to 2. But was it the actual value? This is the predicted value, right? Was it the actual value? No. The actual value could have been this. So the difference between the predicted value and the actual value is called error. Clear? Is it clear what I just said?
Yes.
Right? Let's say, for example, this length that we have, this vertical lines that we have, these vertical lines are nothing but errors. The green line is a predicted line. And these dots, I don't know, blue color or green color, dark green color, whatever this is, these dots are nothing but the actual values. So the difference between the actual value and the predicted value, this difference is nothing but error, right? What we can do is we can make a chart of errors as well. That is called residual plot. Okay, I'll go to linear regression. I'll just search for residual errors in linear regression and let's look at the image. I'm just looking for a chart. Yeah, something like this actually. Something like this, the errors chart will look like. This is even a better example. This is how the residual plot look like. What we do is over the period of time, over the period of x values, we just plot what are the error values. And you will see sometimes the error is positive, sometimes the error is negative, right? That's why it is centered as 0. This is centered at 0 because sometimes the prediction is, sometimes the error is going to be positive, sometimes it is going to be negative. But on an average, it is going to be 0. And what are these dots? These dots are nothing but these vertical lines. Where are those? These vertical lines. We are just plotting a chart of those vertical lines. This is called a residual plot. Okay. One more thing I'm telling you. Am I right in saying that the errors in linear regression are random? Yes or no? Errors in linear regression are random. Is that correct?
That might be
Yes.
true with most data, correct?
That might be true with.
Evenly scattered.
Sorry, I was not able to understand.
So I'm just saying, I might be very wrong. That might be true with any data set, right? Errors are always random. They're not predictable, right? Errors not.
Very, very, very nice, actually. You are right. that errors are always random, and yeah, you are right, right? So sometimes it is going to be positive, sometimes it is going to be negative, sometimes it will be a little big, sometimes it will be a little small, but on an average, the errors are going to always be zero on an average. Okay. If you remember, even in linear regression, there are multiple types of error. There is something called mean. Okay, first of all, which one is the main error? When you want to see whether your linear regression is fitting right or not, based on what value you decide. How do you calculate error in linear regression? You remember MSE? What
Yes.
was MSE?
Mean square
Mean
error.
squared error. Yeah.
Very nice, right? It was mean square error, right? Why we are calling it mean square error? Reason being is in that error, we do we have all the three things. We have mean as well because we are dividing it by n. We have a square as well because whatever the difference between the actual value and the predicted value is, we are taking a square of it, right? So mean, because we are dividing it by total number of values, square error, right? So mean square error. So that is MSE, mean square error. Now, why we are taking a square of it?
Penalize the large errors
So to magnify the errors.
and
Mhm.
to overcome the cancellation of positive and negative values.
Right, right, exactly. So the magnify part was also correct, but the main intuition from where we start with, right, is always that we know in linear regression, sometimes the error are going to be positive, sometimes the error are going to be negative. So if I have, let's say, two, three different lines that I have tried to fit, they will have different error. But it can happen that the errors might cancel out, and for all the three fits, I might get zero error. Right? That's why in case of linear regression, we use MSE, mean square error, because we want to square it. We want to square it to remove the sign of the error. And there is the other value that few people also use. It's called mean absolute error. Remember?
Yes.
Right? So there's something called mean absolute error. Right? So the whole idea behind this is mean absolute error. Instead of taking a square of it to remove the sign, we are taking absolute of it to remove the sign. But why we are removing sign? We are removing sign that because if we will not remove sign, and if errors are random, which they are most of the time, right? So if we will not remove sign, and if errors are random, if we will not remove the sign, they will cancel out each other. Okay? The errors will cancel out each other. So that was a problem in case of linear regression, which forced us to use either MAE or use MSE. Either to take a absolute of it to remove the sign or to take a square of it. But the same thing is going to be in our favor when we will be using time series modeling. Okay, here what we have, here I have different values, right? And these values are changing because in the seasonality component is a fixed value. Every year it is going to repeat itself. But are the values repeating over here? Let's say the green one, if I will pick quarter one, this is quarter one everywhere. Is it repeating itself? Is it the same value for quarter one everywhere? Or am I getting the same value for quarter two everywhere? This orange one? No, right? If this was only seasonality, this value would have been the same. Because as I said, seasonality means it is going to repeat itself. It is a pattern which repeats after a fixed interval. Okay, but it is not repeating. Why? It is not repeating because there is randomness added to it. So what I'm gonna do is, let me maybe try to show you with an example. I hope I will be able to explain this thing. Let's say I have some seasonality component. Uh, let's call it Q1, Q2, Q3, Q4, and let's repeat that value. Uh, right? If let's say I had seasonality value, okay, then the seasonality value is going to repeat itself. Let's say seasonality value 1, seasonality value 2, seasonality value 3, seasonality value 4, and then the same values will again repeat itself. Right? Makes sense? The same value will repeat. Just for our understanding, I'm just going to put some values. Let's say 0.4, 1.2, 0.7, and 1.1. And then the same value will repeat again. The same value will repeat again. Same value will repeat again, and so on. Because this is how the seasonality is. It repeats itself after a fixed time. So if you look at all the quarter one values are same, all the quarter two values are same, all the quarter three values are same, and so on. Right? But is the same thing happening over here? Is the same thing happening over here? No. Am I seeing the same value for quarter three everywhere? No. Am I seeing the same value for quarter two everywhere? No. Uh, so, Bharti, you have a question that can seasonality occur only in specific quarters instead of repeating for all quarters? Can you please explain this question a little bit more? Okay. Like, are you asking, can these two components, say, for example, for quarter one, there is a value, quarter two, there is a value, and then it is 0, 0? If that's what your question is, then yes, that is
Like,
possible.
can it repeat only for like Q2 or only Q2 it will decrease? Can it happen like that, or
So,
it should?
so I think what you are saying is, if I'm not wrong, like something like this, right? That only for, let's say, Q3, I have the values, and other way the values are 0, something like this.
No, for Q1, Q3, Q4, the values will be different, but only for Q2, it will repeat itself. Can it
No, no. So,
happen like?
no, it cannot happen that way, because if so, what you are saying is for Q1, Q2, so for Q2 it is repeating, but for Q1, Q3, and Q4 it is not repeating, right?
Hmm.
If it is not
Yes.
repeating, then it is not seasonality. Okay.
Okay. You mean the entire set of data should repeat itself
No, no, no,
always?
no, no, I'm not saying that. I will explain actually, Bharti. I can understand your
Okay.
confusion, right? But I will explain.
Okay.
I'm just saying that if you look at here, are the values repeating itself? What do you think,
Uh,
Bharti?
No.
No,
No.
right? The values are not repeating here. So when I say the values will repeat itself, this particular values, the set of values that we have, has three components. It has a trend component, it has a seasonality component, it has a random component. Okay? These values are made up of three components: trend component, seasonality component, and random component. The seasonality component will repeat itself. Okay? The seasonality component will repeat itself. But when we will combine the trend component and the seasonality component together, you will see that the values will not repeat itself. Okay? Let's say, for example, over here. Over here, are the values repeating itself?
Yes.
Right? The values are repeating itself. Right? But are the values repeating over here? The answer is no. Right? So, from where this seasonality component is coming? From this time series. And this component is repeating. But is the time series repeating? No. So why that is happening? Because time series is a combination of three components: trend, seasonality, randomness. If you look at only the seasonality component, that will repeat itself. But when we will combine the seasonality component with trend component, the values will not repeat themselves. Okay? We will see in the example as well.
Okay.
Okay.
Thanks.
So what I was saying is that the seasonality component will repeat itself again and again. And this is how, let's say, for example, the values will look like. Right? Some pattern which is repeating again and again. Some pattern which is repeating again and again. Okay, but are these values repeating again and again? The answer is no. Why it is not repeating again and again? Because there is a random component added to it. Okay. Now, the best part is that random component, when you take an average of randomness, when you take an average of random numbers, okay, when you will take the average of random numbers, it will always come out to be zero. Right? This is what we were discussing here as well. The reason behind in linear regression that we calculated MSE, mean square error, or mean absolute error, and not a simple error is because errors in linear regression are random. If you will take a simple average of those average will always come out to be zero, which means the average of random values is always zero. Right? So now what I will do is, so what is happening is, if I had the pure seasonality component, it would have repeated. But currently the values are not repeating. Reason being, it is a combination of seasonality plus randomness. So more or less like for quarter one, I have different values, but different values are nothing but the seasonality component. Let's call it S1, which represents the seasonality component of quarter one, plus some random value. Right? Then plus, so let's say this is for your 20, I'm just taking an example. I do not have these many data points, but okay. And let's say I'm talking about only quarter one for now, only quarter one. So what is happening is I have this column, seasonality plus randomness. I have this column. So it is going to be seasonality plus R1. Next time, some seasonality component plus some R2, because randomness is not going to repeat itself, right? So it will be a different value every time. Seasonality component plus R3, seasonality component plus R4, seasonality component plus R5, and so on. Let me see if I can just extend it. Okay, anyway, so seasonality component plus R6, seasonality component plus R7, seasonality component plus, let's say, R8, and so on. Let me remove the rest of it. And similarly for, let's say, quarter two, if I'll just take quarter two, it is going to be, I will replace S1 with S2, right? So it's a seasonality component plus random component. Let's say, let's call it R dash 1. I'm replacing R with R dash. Right? And similarly for quarter 3 as well, quarter 4 as well, right? I have these values. Right? Now what I will do is I will take an average. Average of what? All of these values. Seasonality component plus R1 plus S1 plus R2 plus S1 plus R3 plus S1 plus R4, right? And so on. I will take an average of it. Divided by total number of values, that is 8. Is it fine? This is how we will take the average. Now, can I write the same thing as this? And let me know if I'm doing it right or not. Can I write it in this format as well? Oh, 5, 6, 7. Will these two give me the same results?
Yes.
Okay. Will these two give me the same result? The first one and the second one?
Yes.
Right? Can I say that the average of the first one, seasonal S1 plus S1 plus S1 plus S1 divided by 8, is going to be S1? Is that right? Right? Like 8 S1
Yes.
divided by 8, right? Which is going to be S1 only. And what is the average of random component?
0.
0. So can I say that if I will take average of all of these values, I will get seasonality component,
Yes.
right? The same thing I can do here as well, that I will take average of all of these values and all the random components will give an average of 0. All the seasonality component will give the average S2. and that average will finally give me the seasonality component of quarter two. This is the important part. If it is not clear, let me know. Give me a minute. I will just have water. Meanwhile, you can just go through this and let me know if you have any question. Right. I hope it is clear. The same way we will do it for quarter two as well, quarter three as well, quarter four as well. And we
Yeah,
will
one
get,
question, Puneet.
yeah.
No, just trying to understand. A seasonality explanation, you have taken some random figures which is having same for all quarters, is it? In the first,
Right. Because seasonality, like you're referring to these values, right?
yeah, correct.
Right, right. So here this is an example. So the values are random, but the concept is correct that the value will always repeat itself for each quarter. Okay.
But my
So
question is it in general it will repeat actually, or based on some nearest, so it is a nearby value for each quarter, then you are taking like it will repeat in general. Just I'm curious.
no, no. So see, as I said, seasonality mean by definition itself that it is going to repeat, right? It can repeat over quarters, it can repeat over weeks, it can repeat over days as well. Let's say, for an example, if you will talk to any barber, right, in India, you will see that there is also seasonality. Then that let's say Sunday, Monday, you will have more customers as compared to Tuesday or Thursday or Saturday, right? Because in India, like we have this belief that we will not cut our hairs on Tuesday, Thursdays, and Saturdays. There will be lesser number of people for haircut. So for a barber perspective, is the seasonality coming yearly? No, it is coming every week, right? Right. So the same way, let's say from a AC company's perspective, the seasonality is not coming every week. It is coming every year.
Yeah.
So the seasonality can happen over quarter, can happen over years, it can happen over days as well, or over weeks, right? But the definition of seasonality is that it is going to repeat itself, and it is an approximation. See, all the prediction that we make, like if I will ask you this as well, I showed you this chart, right? Is this line is actually same as these data points? No. What we are doing is this line is nothing but an approximation, our best guess for these points. Is that right?
Yeah.
Even with the seasonality, right? Every year it is not going to be exactly the same. Let's say if I will say that in case of summer, your AC sales is twice as much as it is in winter. Okay. In summers, our sales is twice as much as it is in winters. So the seasonality component for summers will be 2, right? But does that mean that every year it is going to be exactly twice?
No.
Sometimes it can be 1.9 times as well. Sometimes it can be 2.1 times as well. Sometimes it can be 1.7 times as well. Is that right?
Yeah, correct.
Right? Now, this variation that we have, that sometime it is 1.9, sometime it is 2, sometime it is 2.1, sometime it is 2.15, right? This variation that we have, we count that variation in randomness.
Okay.
You get my point? And then we take an approximation that every year seasonality is of 2 only. That our sales ideally should be twice as compared to the winter sales. But whatever the variation is coming, that variation is coming because of the randomness. Right? So it can happen that it is not actually random. There are factors behind it. But the point being is we know that approximately on an average every year the sales is twice as much because you need to make a prediction, right? You need to make a prediction. If I will tell you that um, 1 year the sales was 1.7 times, 1 year the sales was 1.9 times, 1 year it was 2.1 times, 1 year it was 2.2 times, 1 year it was 2 times. Now I'm telling you, Suman, please predict how much more the sales is going to be in summers as compared to winter next year. What will you do? You will say that, okay, what I will do is I will take the average of the past data. I will take the average of the past data, and that is what is going to be my prediction for next year. I will say that it is going to be 1.98 times next year. But is it going to be exactly 1.98 times? No, right? But that is your most educated guess. You got my point,
Yeah, yeah, I got it.
right? So seasonality, obviously, it can be a little bit here and there, right? But that here and there is getting counted in randomness. That's why we have these values which are exactly repeating itself. And later on, I will show you in the Python as well using machine learning technique. It works exactly the same way. It will decompose your time series into 3 parts: the trend component, the seasonality component, and the error component, or sorry, the random component. And you will see that even over there, the seasonality component will exactly repeat itself. Okay, let me maybe show you, maybe I will be able to get it. Airline data time
This
series.
average, only one question, sorry to interrupt. That
Yeah.
average of that random also, that is also some approximation nearby zero value, is it?
Right, right.
Okay, fine.
Okay. So let me show you. This is the data that we are also going to use later. Okay. This is observed value. That is the actual value. We decomposed it and then we got a trend value. Is this the perfect straight line? No, right? The trend component, is it a perfect straight line? No,
No.
right? It is a approximate straight line. Approximate straight line we have. But look at the seasonality component. Is it not exact copy paste, control C, control V, control C, control V?
Yes. Repeat.
Right. So even there, let's say, I'm not saying that we are doing any approximation while doing it in Excel. No. When you will do it in Python as well, even there, the seasonality component will be exact. Control C, control V, control C, control V. Reason being is that is what the definition of seasonality component is. Seasonality component should repeat itself. And whatever the variation is there, that is going to be absorbed by error. Sorry, randomness. Okay, I will not confuse you more, but I will tell you very interesting thing here. Can you see, can you tell me something from these four charts, which is in contradiction of what I have taught today? Okay, I don't want to confuse you, but it is a very interesting part, so I thought of mentioning it. Can you see anything in these four charts which is in contradiction of what I have taught today? There is a there is something that I have said again and again in this class today, and that is not true in one of these four charts. Something which I said always happen, will always happen, but it is not true here.
I think from again first one.
Residue.
Sorry.
The residual is not zero. Told it will get
Very nice.
cancelled.
Very nice. Very nice, Bharti. Right? So from the starting of the class, I'm telling you that the residual will always average out to be 0. The residual will always be centered at 0. But here the residuals is not centered at 0. Where it is centered, any approximation? If you would have to pick a number.
1.
1. Very nice, right? There is a reason why it is centered at 1 and not at 0, right? I will tell you that thing later. Okay, you'll find it very interesting. This is a very interesting point. Okay, but there is a reason that why it is not centered at 0. Okay, I will discuss that. For now, let's forget about it and let's get back to here, right? Where we know that the randomness will add up to the average will always be 0. Now, we know that we need to find the seasonality component. How we are going to find it is, I will take average of all the quarter 1 values. Let's say, let me first go to quarter. Sorry, my bad. I will take average of all the quarter 1 values. This is quarter 1, the green value. The next quarter 1 value, green value. And the next quarter 1 value, that is this green value. More the data points that I will have, the better is going to be my average. Reason being is obviously just by 3 data points, the averages will not, the residuals will not cancel out each other. Okay, but we are just doing it from a learning perspective. So we will assume that it will cancel out each other, and this is what the seasonality component is. But I'm just letting you know for your information that I need enough number of data points for the residuals to cancel out each other. It is not going to cancel out each other in just 3-4 data points. We need at least 200-300 data points.
You're not taking you're not taking D6. I mean, the
D6.
sixth row. I mean, G6. G6.
G6. G6, we do not have the value, right?
Okay.
Here you are asking, G6, right?
Okay.
How seasonality plus randomness is calculated by subtracting the actual value minus the trend value, right? The trend value is not present here for these two.
Okay.
And
Yeah,
why it is not present for these two and these two?
It doesn't have values previous
Right,
to
exactly.
get the.
Because we need 2 values from past, 2 values from future. If to calculate the centered moving average here, I do not have 2 values in the past. Okay, so because the trend component is present only for this much, I will able to calculate seasonality plus randomness only for this much area.
Yeah, thank you.
Okay. Now, the same thing. So what I did, I calculated average of all the quarter ones. Then I will take average of all the quarter two values. That is, I believe, this orange one. Then I will take average of all the quarter three values. Quarter three is this yellow one. Then I will take average of all the quarter four values. That is this white one. Okay. The next part is easy. All I have to do is just repeat the values. Right? Seasonality component will just repeat itself. So once I've calculated these four values, all I have to do is copy paste, copy paste, copy paste. Clear? Can you please do it yourself once? And if it is not clear, let me know. Calculate the seasonality component. Let me know when it is done. Once you calculate the four values, just repeat them. Okay. Now we have a trend component as well. We have the seasonality component as well. And if I want, I can also get the randomness component out of it, but that will be useless because I'm not going to use it to make the prediction. So what is going to be the next step? You have this blue line. You have this blue curve again here as well. What should be the next step?
To predict.
What is your guess?
To predict trend and seasonality over the period of time.
Very nice, Keshav, right? So we need to predict the trend and seasonality. How do we predict this? By regression, right? If it is a line, the best way to predict it is going to be regression. Okay. So what I will show, let me show you. Let's say if I talk about, let's say like this. Mm, not a very good one. 1 minute. Plotted the one. Let's say if I want to predict the values for what is going to come next, what is the best way to do that? Regression, right? This is a classical problem of regression. In regression also you have some data points and you try to fit a line through it. Okay. Now what I will do is, okay, first create this chart. How I have created it is, I selected this data and now press control and select this data as well. Go to insert and just create a scatter plot. Now it is coming like this. Okay. So this, then this, go to insert. Okay. Create this scatter plot. How I hope you guys are doing it side by side. Now click on the chart. If you click on this plus, if you click on this plus, uh, there is a option of trend line, and I can say linear trend line. That is a linear. It is nothing but linear regression itself. It is a linear regression. Okay. If it is not coming from here, you can just click the chart, then go to chart design, add chart element, and even from here you can get the trend line, linear. Okay, so both the options are there. Get that trend line.
Can you show it once again, please?
Yeah, sure. How to get the trend line or how to get the chart or both?
The trend line.
Yeah, sure. So I said there are two options. One is that you can just click on the chart. There is a plus sign and then the trend line. And I can just simply select linear over here. This is one option. But in some versions, I have seen that this plus sign will not come. So in that case, you can just simply click on chart, go to chart design, here add chart elements, and here trend line, linear. Right? Once I have the line, just line is not enough. What I want is in linear regression, just the line is not enough. What do we want? What do we want in case of linear regression? We want the equation. So I'll click on the line, press Control and 1 together, Control and 1 together, and then there is a option of display equation on the chart. This, right? If you don't want to do it like this, again, if you have a problem doing it this way, go to chart element, trend line, and there is option of more trend line options. So just click on that, more trend line option, and just click on display equation on the chart. Okay, now I have this equation y is equal to mx plus c. What is x here? X is nothing but 1, 2, 3, 4, like this. So what is going to be my trend? Y is equal to mx. What is m? 0.1476 multiplied by x, that is 1, plus c, that is 3.1591. Is this right?
Yes.
Right? So I'm just gonna control C, control V here. Right? Very simple, just equation of line I have written. This is nothing but my trend component.
Puneet, can you please repeat how did you get that y is equal to mx plus c value in the plot?
Yeah, sure. So what I did was I went to list chart design. Okay. Chart design, trend line, and here more trend line option. If you click on that, here there is the option of display equation on chart. Okay.
Okay, yeah, thank you.
Where is that option? Manoj? Chart design option. Sorry, not able to see.
Here, display equation on chart. So once you click the chart,
No, no, no.
go to,
This chart design option is I'm not able to see.
have you clicked the chart once? Click the chart. Without that, it will not be visible. You need to click the chart. Then it will be visible. Is it not visible even now?
The chart design option is there. Chart tools, chart design. After that,
Yeah. And there, add chart element,
okay.
trend line, and even here, more trend line options.
Okay. Thank you.
Okay. And that's then I use this equation to come up with the prediction.
So we are essentially deriving that equation using charts, is it?
This equation you're saying?
Yeah, mx plus c.
Right, right. Not exactly chart. In the background, actually, it used linear regression itself. So this is the equation of linear regression. So if you will take these data points and put it in a Python and then try to do a linear regression, you will get exactly the same line.
Okay.
Okay. And I will show you as well. Again, when I will do it in Python, there I will not be making out of chart, right?
Hmm.
There I would have to use linear regression, and you will see that I will get exactly the same equation even there.
Okay. Okay.
Okay. Now predicted value is going to be what? Predicted value is going to be nothing but the trend component plus the seasonality component, right? Because there cannot be any random component, right? So the trend component plus the seasonality component is going to be my predicted value. So this is what my final predicted values are.
Puneet, how did you calculate this predicted trend? Can you show the
Right.
formula?
Sure, sure. It is nothing but seasonality component because it is going to be fixed plus the trend component.
Okay, this one, this column number I predicted trend one.
Yes, right. INH.
Okay.
Okay. Now, once you have the predicted value, you will calculate the error. Okay. And calculate the error by actual minus predicted. The actual value minus the predicted value. That is what my error is. Actual value minus the predicted value. Okay. So before we do anything else, let me just show you how my prediction versus the actual values look like. Now, let's see whether it is even close or not, right? Yeah, this is. So the blue line that we have over here is the actual line, and the orange line that we have over here is a predicted line. So I believe more or less we are doing a decent job, right? Mm, now you can see the actual line as well and the predicted line as well. So I believe we are doing a decent job with the model that we just created out of Excel.
Yes.
Okay, the same way, once this is done, we can obviously calculate the mean absolute error and mean square error, but we will do that later. Let's quickly go to multiplicative model. Okay. In the multiplicative model, we will start with the same thing. I'll calculate CMA5. CMA5 is nothing but average of past two values, current value, and the future two values. Then I will get seasonality multiplied by randomness. Why? Because sales is going to be trend component multiplied by your seasonality component multiplied by your randomness component. So once you have a trend component, can I say sales divided by trend component is equal to seasonality multiplied by randomness component,
Yes, you can say.
right? So what I will do is, once you have the trend component, you will calculate the seasonality multiplied by randomness component by dividing these two. This divided by this. And then you take the average of all the seasonality, same thing, right? Can you just try it? We will quickly do the multiplication one as well. First calculate CMA5.
I have a very naive question. Like, how do you apply the formula to all the rows? I mean, for 3.4 you did, and you applied it to all of the rows. How did you do that?
Right. I think what you might be doing is you do Control C and Control V, right?
Yeah,
Is that right? And the problem will be that it will copy paste the format as well,
looks like that. Yes.
right? So what I'm gonna do is I'm gonna do Control C. Let's say if this was not there, I'll do Control C and I select the area and Alt H V and then F. F is for pasting the formulas. Okay. Here F, if you look at it, it is for pasting the formulas.
Okay.
So what I was doing was that whenever I don't want to change the format of the rest of the line, I do this, just do Control C, select this area and Alt H VF. Okay, and then I selected this actual value minus or divided by trend. Control C, Alt H VF. Or other way can be that you can go to the paste, and even here there is the option of pasting the formulas.
Mm. Okay. 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 Yeah. Thank you.
Sure, no problem.
But how you got 3.4? Can you show the formula? I'm getting something wrong.
Sure. This one?
3.4, 3.
3.4.
Yeah.
Okay.
Okay, okay. From E5T. Yeah, okay, got it. Thank you.
Once you have the seasonality multiplied by the randomness component, we will take the average of all the quarter ones, the same thing that we did. We took average of all the quarter ones. We will take average of all the quarter twos. Similarly, average of all the quarter three. And all the quarter fours. And then I will just simply repeat the seasonality value. Okay. The same way I will be calculating the trend component as well. So I'll just select this and the CMA5, go to insert, and here I will add the trend component. I think it is the same one, 0.1476 multiplied by 1 plus 3 point. Predicted value is going to be nothing but the seasonality component multiplied by the trend component. Okay. Seasonality component multiplied by the trend component. That is going to be my predicted value.
Puneet, how you calculated this predicted trend one?
The same thing. This equation you have, right? The one
Okay.
that we had last time as well. This equation is same. So we just got 0.1476 multiplied by x. What is x here? These 1, 2, 3, 4, 5, 6 multiplied by x plus c. This is the c.
Okay.
Okay, equation of line.
Okay. Got it.
From where the CMA value comes?
Sorry.
CMA, that is the column F. How does this value
Right.
gets populated?
Like this. So we have taken the average of two past value, two future value, and one current value.
So average E5 to
To
E9.
E9. Yes. So let's say now I think it would be better to read like this. Two past, two future, one current value.
So adding all those 5 values divided by 5.
Yeah. So yeah, exactly.
Average, okay, average,
Yeah.
okay, it will
So we are
automatically.
already using the average function, so it will be doing that automatically.
Okay, okay, thank you.
Can you show the formula for star band?
Yeah. Right. So this is nothing but, as we discussed over here, right? Seasonality multiplied by randomness will be same as sales divided by the trend component, right?
Yeah.
So this.
Okay. Okay.
Okay. So error, I'm going to directly calculate the absolute error, right? The actual value minus the predicted value. Okay. We can use this function ABS. ABS is going to give us the absolute value. Okay. So this will give me what is the absolute error. Let me call it absolute error itself. Then I will calculate the square error. Square error, I can just simply take a square of absolute error itself. 0.1 multiplied by 0.1. And then I will calculate the mean absolute error, that is the average of this whole thing, and mean square error, average of this thing. Sorry, my bad. Ideally, I should not calculate error here because there is no actual value. Right? So this is mean square error. Same way I will do the calculation here as well. Then I will take average of this, average of this. So this is for additive model.
Puneet, how square error is calculated?
So what I've done is, I just multiplied these two together.
Okay.
Okay. Let me calculate for multiplicative as well. I'll bring it here. So if I will compare the errors of additive assumption versus multiplicative assumption, this was the assumption that we made, right? That the time series is additive, then we solved it, then we made the assumption that the time series is multiplicative, and then we solved it, and we realized that if I will make the assumption that time series is additive, it is going to give us lower error as compared to when I will assume the time series is multiplicative. Okay. So if I was doing it, let's say, on my job, I would have taken the assumption of time series being additive and went forward with it because that is giving me the least error. Okay, done. Any question? Anyone?
I have one very basic question.
Mm-hmm.
Now, the activity we did today in terms of
Mm-hmm.
time series, so this
Mm-hmm.
was to figure out which is the best approach for evaluating the data. Is that right?
Okay. Yes.
So, it's
Mm-hmm.
like additive versus multiplicative. How do we choose? Is that what we did today?
No, no. So that was not the idea. The idea for today's discussion was that uh, like any time series modeling that you will do, any time series modeling that you will that has some basics, right? The base will always be that we need to decompose a time series into three components: trend, seasonality, and randomness. And then we need to predict them individually. Then we need to combine them together. That makes the most basic modeling structure, right? So this is what I can say is the most basic one. Now, from next point onwards, like say the next step is going to be we will implement whatever we have done in Python. That is the first step. Second step is we are gonna learn more complex models from here, right? And we will see whether those models are giving us better accuracy than this or not. Okay.
Okay.
Why we had this discussion today is that tomorrow, if someone asks you a question related to time series tomorrow, right, you will have a fair bit of idea how time series is done. Even whatever we have covered today, right? If someone asks you anything related to time series in an interview, even if you will tell this much, I'm telling you, it is far better than yeah, like many other people who know far more than what other people know. Because what we are going to see tomorrow is that most of the time series functions are just packages. Okay, there is something called FB profit that we're going to use tomorrow. You will see it's kind of like a black box. You will put your data into it and you will get an output which will give you a very good accuracy. But what all is happening in that package is something that we will not be knowing for sure.
Okay.
Okay. So
Got it.
if like I cannot tell in an interview that I just used a package and it gave me a good accuracy, right? So in an interview, if I need to have a discussion, I will have the discussion in this way.
Okay. Okay. Thank you.
Okay. So whatever we have discussed today, that is first reason is to know the basics. Second reason is to kind of, if someone will ask me in an interview, at least I have a full approach clear in my mind. And the third thing is that tomorrow, whatever we will be doing, you will realize that from understanding perspective, from accuracy perspective, it will give you better result than whatever we have done today. But from an understanding perspective, you will realize that most of the time I will be telling you that this is the package that we are going to use to get this result, rather than how that package is working.
Perfect. Okay. Got it. Yeah. Thank you.